Alright guys, number 6 is not that hard, but you do have to know what it's asking for. So you have the following function, h of x equals blah blah blah, nobody cares. See? You have that x has to be greater than 1. Let's understand why. So here, where is x? X is right there. It's in the denominator and it's also in a square root. So square root of x minus 1. Now, you guys, for a square root, let's say you have square root of, I don't know, 9. It's going to be 3. Square root of 8. It's going to be some number, right? A little less than 3. I don't know, 7. You can keep going. You're going to get the idea. See? Point is, notice what happens when I enter the realms of negatives. It's very interesting what happens. So square root of 3, which number multiplied by itself gives 3? That number. So this times this is going to give you 3. Okay, that's what the square root does. Nice. Square root 2 is 1.14, I think. 1.414. Sure. So this times itself should give you 2. Correct. Square root of 1, it's going to be 1. Square root of 0, it's going to be 0. So this is still legal. But the moment you end up with negative 1 inside, you get what is called a non-real answer. So technically, right here, the answer is an imaginary number. Guys, thankfully, I don't have to explain what imaginary numbers are and how they work, other than just me saying imaginary numbers is for negative sort of square roots, okay? And it's important to understand this because it helps you define your domain. And so your domain wants to avoid imaginary numbers, and so x is to be greater than 1, so that this square root is always positive. What do I mean by this? Clearly, we don't like negative a negative value, sorry. We don't like a negative value in our square roots. And so you want to keep this always what's inside greater than or equal to 0. And so, well, whatever, you can leave it as just greater than 0, see? And so here, you do plus 1 on both sides. X has to be greater than 1 for the square root to remain positive. And that is why x has to be greater than 1, see? Alright, that was a little bit of blah blah, but I think it might help for finding the domain down the road. It's important to keep it in mind. Eso, okay? So, for part A, we need to find h exponent negative 1 with a 1 inside. So some of you are probably reading this and saying, that's a derivative. And I would say, excellent guess, I like the energy, but a derivative would look like this. It's with a little bit of an apostrophe, see? Actually, I think it was for number 3. For number 3, you have this apostrophe. So this is for derivative, okay? And this over here is what they call the inverse. Okay, this is for the inverse. And now let's understand how to get the inverse. Let me make a simple example first. Imagine you have, I don't know, y equals 2x plus 3, okay? And so to find the inverse, the first step you're going to do, and pay very close attention to this, the first step you're going to do is you're going to flip the x and the y. So you're going to end up with x equals 2y plus 3. And from here, you want to get y alone. So you're going to do minus 3. Minus 3, it's x minus 3 equals 2y, and then divide by 2. So y is going to equal, just that, x minus 3 divided by 2. See? And so notice the first step that is very important is change location of y and x. See? If you get very fancy with this one up here is the same as f of x equals 2x plus 3. And this one down here is the same as the inverse of f of x equals x minus 3 divided by 2. And so the last step you can do is sort of like plug in, the f of inverse or f of x. But strictly speaking, this is just y, and this is also just y, just that the y in the version of inverse, okay? So you want to find the inverse, but also plug in x equals 1. Okay? And so let's be very rigorous in our approach. All right, something cool about this exercise is that the method is very, let's say, reliable. It's always the same one, yada yada. See? So the first thing you're going to do, as I said, well, just write down your equation first. So you're going to have h of x equals 2 divided by square root of x minus 1 plus 1 half, right? Now let's remember that h of x is the same as y. So I'm going to write y equals 2 divided by square root of x minus 1 plus 1 half, right? Now you're going to do the first more important step, or second important step, whatever. Change the location of y and x. I mean, like, flip them, right? So you're going to end up with x equals 2 divided by square root of y minus 1 plus 1 half. And so from here, technically, because they want an x of 1, you can plug in an x of 1 right away, all right? Or you can do it at the very end. For our intentions, or just for me to explain it more clearly, we're going to plug in 1 at the end, okay? What I'm going to be finding is just the inverse function, and then I'm going to plug in 1. See, I just want to be like a little more clear in my approach. And so from here, well, clearly you want to get a y alone, but y is in a square root, so it's very hard to deal with. So the first thing I'm going to do is I'm going to try to get y alone, so I can do minus 1 half, minus 1 half. So this goes away with this. You end up with x minus 1 half equals 2 divided by square root of y minus 1. And yes, from here it's sort of annoying to solve this, right? And so what you can do is that you can square everything. See? So if you can square this whole side, and you can also square this whole side, right? So what you end up with is that on the left side it's x minus 1 half times x minus 1 half, right? Equals, up top it's going to be 4, and on the bottom it's going to be just y minus 1. So this is a little bit easier to deal with, see? And so from here you actually end up with x times x squared, minus x1 half, minus x1 half over here, right? Plus 1 over 4. All of this equals 4 divided by y minus 1, right? And so because you want to get y alone, or actually, guys, I know that I said first I was going to find the inverse, see? But, and I'm just going to show you, I'm not going to cut this off the video because I think it's important that a lot of times you're doing your math process and you realize, there was a smarter way to do this. So I'm just going to leave it on the video, okay? Point is, I was trying to find the general form, see? But what did I encounter? I ended up with a bunch of x's over here, an exponent. It started getting a little bit weird, a lot of different terms. It would have been harder to solve, okay? So what I'm going to do is I'm going to back it up, Terry. I'm going to back it up a couple steps, and I'm just going to plug in that one that they told me right away. Why would I do this? Because it's going to make my exercise a lot simpler to solve. I'm going to end up with less stuff going around. And so on this step here, I'm going to choose, like right now, I'm trying to do this, but now I'm going to plug in an x of 1. See, so if I plug in x of 1, I end up with 1 minus 1 half equals 2 divided by square root of y minus 1. And so clearly this is way more friendly. You end up with 1 half equals 2 divided by square root of y minus 1. And so from here, what you can do, okay, from here what you can do is that to get y alone, okay, you can multiply, you can cross multiply, okay? So that means I end up with 1 times square root of y minus 1 equals 2 times 2, okay? So that means you end up with square root of y minus 1 equals 4. In order to get rid of this square root, you can do everything squared. Make sure you do it to both sides, so this goes away with this. You end up with y minus 1 equals 16. 4 times 4 plus 1, y equals 17. Now what does this mean technically is that when you have your inverse and you plug in 1, you get 17. Okay, that is what we just did, and that is for part A. Later on, we need to find the domain of the inverse of h. Now, technically, I could find the general form and find the domain from there, okay? The thing is, as you guys saw earlier, you end up with a bunch of square roots, you end up with a bunch of exponents, you end up with a lot of different x's. It's pretty hard to solve, see? And I'd rather show you maybe a more direct way to solve it, okay? The more direct way to solve it is that, and this is a general rule, so write it down somewhere, okay, you guys? A general rule that you can say is that the domain of f of x is going to be the range of the inverse. Actually, I'm just going to put range of inverse. See? And something else you can say is that the range of f of x, it's going to be the domain of the inverse. And so if you're trying to find the domain of the inverse for part B, all you need is to find the range of f of x. So what is the range of this equation? Well, first things first, maybe I should have said this earlier, but domain is the possible x values. While the range, you guessed it, is going to be the possible y values. And so what I can do is that I can put up my graphing calculator and say, yo, I need your help once again. I am asking for your assistance. And so you're going to put a fraction here by pressing alpha y equals. Tapping on the first one, you end up with 2 divided by square roots of x minus 1 plus, oops, my bad, plus your fraction right here, see? 1/2. Now, as you can see, these numbers are very small. You literally have an x plus 1/2. So I would suggest that to get the right window, go to zoom and do zoom standard, okay? Why do I suggest zoom standard in this case? Because zoom standard makes a window of everything equal to 10, okay? And as you can see from here, it's much easier to see how I should maybe change my graph. So clearly, I only care about positive values, like positive x and positive y, so I can, put an x min of 0, put a y min of 0, and now my graph is only on the positive side. It's much easier to interpret. And so as you can see, what are my possible y values? Well, if I go ahead and graph this for a moment, what we found was something that looks like this, okay? And so clearly my y values, well, they go up to infinity for sure, right? Up here. But do they stop somewhere here? Do they stop somewhere here? And the answer is yes. Now it's very important to understand how far would it go. So are you guys, so as I was saying, if you find the range of f of x, you're going to find the domain of the inverse because they are the same one. And so if you go ahead and graph over here, right, as I showed you, you end up observing, right, that that your function, right, seems to reach an asymptote on the horizontal, right? And so basically your y equals is gonna like grow a lot, right, over there, but eventually it's gonna find a horizontal line here. And so the hard part now is finding what is that horizontal part, and wherever that horizontal part is, you're gonna say that your y values are gonna be everything in between. See? So you're gonna find sort of like that edge, right? Its limit. And so one way to do this, and what they suggest, is that for horizontal asymptotes, I'm actually gonna write this, for horizontal asymptotes, put a large value on your table. Why is it this way? Because for horizontal asymptotes, for example, this is, I don't know, y equals 1, y equals 1/2, like we're about to find out, see? And so the bigger your x value, eventually you're going to find, so that's the value that y never reaches, see? I know that might sound weird, but for now, follow the process. Pull up your calculator, go to table, and scroll all the way down, see? Eventually, it's going to be very obvious which y value you're never going to reach. Now, as you can see, you can be scrolling for quite a while. So what you're gonna do is that you're gonna press this blue button, second window. That way you hit table set. And what this allows you to do is that you see how you have this little triangle table. This is by how much each value changes. So for example, if I put a table of 2, and again I start at 0, and I go to my table, look at these x values. It goes from 0 to 2, 2 to 4. So now your scrolling is a lot faster, right? But you are in the context of a test. So you don't care about your table looking pretty. You just care about the answer. So your table is going to start at 0, but it's going to change by an incredibly large number. Yes, just do it. Incredibly large number. You go to your table, you start scrolling down, and basically by now you're like at infinity. I mean, not really, but you're giving some incredibly large x values. And what y value do you never reach? 0.5. Clearly, you never reach 0.5. You get very close to it, but you're never going to reach it. That is your horizontal asymptote. Your horizontal asymptote is at y equals 1/2. So if you never reach y equals 1/2, that means all of these other values are y is greater than 1/2. And so the range of f of x is y greater than 1/2, and so the domain of your inverse, because it's domain, because it's x values, is going to be x greater than 1/2. This is a math rule you can always apply. I heavily suggest you write this down somewhere. It's very big brain stuff, and it's probably the quickest way to do this. The other way to do this is that you find the OG inverse function. But as you saw, even it's not that I got scared of it, but even I said like, dude, that would take way too long. You have like a quadratic going around, you have exponents, this or that. This is the more quick way, see? Remember to change your table set, okay? This is the big hint. A lot of the IB is just understanding how your graphing calculator works and all the tools that are inside of it, okay? So, make it start at 0, maybe put it back to 1 for a future example, but, so that you can analyze your graph more clearly. But for finding asymptotes, just put an incredibly large number and it's going to make sense, okay? Even if you put the largest possible. Here I put all the zeros I could. Clearly, y reaches that 0.5, see? So it's never, whatever. Your domain, the range of f of x is 1/2, so x, so the domain of the inverse is the same thing but with an x instead of a y, see? So enough blah blah. For uh, for part 6b, you would say that the domain of h of inverse is x greater than 1/2. What is your argument? That the range of the OG one is 1/2. So ladies and gentlemen, that is how you solve number 6. Not that hard, but you do need to understand the procedure of the inverse, okay? Remember, change the location of y and x, and from there everything just kind of flows. They usually ask for domain and range, and so this tool here is going to do wonders for you, okay? Ladies and gentlemen, that is for number 6, and I hope it helped.